August 1934, Enfield Lock, North London. A group of British Army officers gathered on a firing range to watch the most punishing endurance test the Small Arms Committee had yet devised. Two light machine guns were mounted on their bipods and prepared for an ordeal meant to separate the merely good from the exceptional. 50,000 rounds of continuous fire, run until something failed. One entrant was a domestic design, the Vickers-Berthier, a promising homegrown contender. The other was an imported Czechoslovakian design, the result of work by Václav Holek in Brno, part of the ZB family of light machine guns. When the smoke finally cleared and the run finished, the Czech weapon was still operating cleanly, so reliable under continuous stress that Enfield recommended adopting it. The British did not simply take the ZB off the shelf and issue it as is. They modified and reworked it at Enfield to suit service with the .303 British cartridge and British manufacturing practices. The name they gave the resulting weapon fused its two origins, Bren from BRNO plus Enfield. Within a few years, German soldiers would be stripping Brens from battlefield casualties and captured depots, not because they preferred them to their own guns, but because even the enemy recognized the quality of the engineering they had seen. This is the story of a machine gun that looked ungainly, fired at a modest cyclic rate, and yet became perhaps the most cherished infantry weapon of the Second World War. The problem facing British infantry in the 1930s was blunt and urgent. The Lewis gun, which had served through the Great War, was no longer adequate. It was heavy, more than 12 kilograms in service trim, used cumbersome pan magazines that were awkward in the mud and sand of real battle, and was prone to stoppages. British soldiers needed a lighter, more reliable automatic rifle-class weapon that a single man could carry and deploy with a single assistant, accurate enough to put controlled bursts on target across the long ranges encountered around the Empire, rather than sweeping everything with indiscriminate volume. Germany had gone down a different path. Their MG42, and later the even more fearsome MG42, emphasized a very high cyclic rate of fire. The MG34 could hit roughly 900 rounds per minute. The MG42 pushed that to roughly 1,200 to 1,500 RPM. German infantry doctrine built entire squads around the machine gun. Riflemen existed to feed ammunition belts and protect the gun. That philosophy produced huge volumes of lead and a terrifying psychological effect, but it also demanded prodigious ammunition logistics.
British doctrine, shaped by imperial service in deserts, jungles, and Arctic wastes, and by the realities of long supply lines, emphasized something different: accuracy and thrift. Ammunition was a precious commodity when your supply chain ran thousands of miles. Commanders wanted a light automatic weapon that conserved rounds, delivered accurate bursts, and could be served by two men rather than a 3- or 4-man team. Enter Václav Holek's ZB family. When the Czech guns arrived for trials, their gas-operated mechanism proved impressively dependable, and their quick-change barrel allowed the gun to sustain bursts without melting the core. The top-mounted curved magazine, odd to officers used to bottom feed, had practical benefits. It allowed the gun to be fired from a lower prone position, while an assistant could stand to the side and reload without disturbing the gunner's sight picture. The British did not copy the ZB mechanically and leave it alone. Converting the design from the metric 7.92mm Mauser cartridge to the rimmed .303 British round required significant redesign work. The familiar curving magazine is there for a clear reason. A rimmed cartridge stacked in a straight column tends to suffer rim lock, one rim catching the one behind it. So the magazine geometry had to be changed to prevent feeding failures. Enfield craftsmen shortened the gas tube to compensate for greater fouling produced by British cordite propellants. They added a dual buffer spring system in the buttstock, one spring to absorb the butt plate impact, another to return the piston, which both tamed recoil and allowed a trained gunner to deliver controlled 5-round bursts with grouping comparable to 5 aimed rifle shots. Trials at the Royal Small Arms Factory recorded the finished weapon as weighing about 22 pounds empty, 45.5 inches long overall, with a muzzle velocity of roughly 744 meters per second, and a practical cyclic rate around 480 to 540 rounds per minute. That slower cyclic rate was deliberate. The Bren was designed to make every round count. Production began at Enfield in September 1937. By the time war erupted 2 years later, more than 30,000 Brens had been issued to the British Expeditionary Force. They were about to be tested in earnest. Then came Dunkirk. The collapse of the Allied position in France in May-June 1940 cost Britain dearly in equipment. After the evacuation concluded, only about 2,300 of the roughly 30,000 Brens that had been issued had made it back to Britain. The rest lay in French mud, abandoned or captured. Britain suddenly faced the prospect of invasion with only a fraction of the small armored and small arms equipment it had planned on. Working light machine gun stocks were dangerously low.
The Germans promptly cataloged captured Brens under their system for foreign weapons. They designated them the 7.7mm Leichtes MG138E, the E indicating English origin, and used many in occupation and second-line units where 303 supply could be assured. Captured Brens were also used by security and anti-partisan formations. There are accounts that Germans valued Brens taken from captured stocks for use in rear areas. However, claims that the Wehrmacht prioritized Bren recovery above all other captured weapons should be treated cautiously. The German military cataloged and exploited captured equipment systematically, and while the Bren was useful, there is scant evidence of any special, documented priority for it over their reliable MG34s and MG42s. What followed in Britain was an industrial answer the country's planners had to have hoped for: retooling and mass production at a scale adequate to replace the losses. The original Mark I Bren required precise machining that limited output. Designers simplified the manufacturing process and produced the Mark II with methods that reduced cost and increased speed, cutting production expense by roughly 20 to 25% while keeping combat effectiveness intact. Manufacturing was dispersed across the Empire and the Commonwealth. The Monotype Group Consortium started production in September 1941 and ultimately produced tens of thousands. John Inglis & Company in Toronto manufactured more than 186,000 Bren guns, which by 1943 represented roughly 60% of global output. Lithgow in Australia made over 17,000. Ishapur Arsenal in India began production in 1942 and continued manufacture for decades. By 1943, British and Commonwealth industry was turning out roughly 1,000 Brens per week. A crisis in 1940 had been turned into an industrial triumph. Combat veterans' accounts consistently praised the weapon's reliability and the accuracy it brought to section fire. Lieutenant Jimmy Langley of the 2nd Coldstream Guards wrote in his memoir about Bren fire during the desperate Dunkirk rear guard actions. When Germans emplaced a machine gun in a ruined cottage across a canal, a Bren team blasted them away before they could bring it to bear. In the grinding fights of 1940, there are reports of guns melting firing pins under the sheer intensity of use, and of battalion commanders taking over the weapons when the line thinned. Scenes that testify to the Bren's status as the tool that could hold a position longer than expected. Bren gunners won the VC more than once because the gun allowed a single operator to hold otherwise untenable positions. Rifleman Sher Bahadur Thapa, 9th Gurkha Rifles, posthumously won the VC at San Marino in 1944. His citation records that the intensity and pinpoint quality of his Bren fire silenced multiple enemy machine guns and held the crest under intense pressure. Corporal Thomas Peck Hunter of 43 Royal Marine Commando famously charged across open ground firing his Bren from the hip in April 1945. 6 Germans surrendered to him before he fell. The Bren's performance in extreme environments underscored both its virtues and limits. North Africa's fine sand tested every weapon. The Bren could jam if not kept scrupulously clean, but its 4-position gas regulator allowed gunners to tune the weapon for changing conditions. The minimum gas setting for hot, dusty desert to reduce fouling, higher settings for cold climates where more gas was needed. Field experience taught soldiers the practical rules of thumb. A firm tap, a regulator twist, or both fixed many stoppages. The Mark III variant, standardized in July 1944, addressed jungle warfare needs. A shorter 22.25-inch barrel and a lighter weight of 19 pounds 5 ounces made it far more suitable for Burma's dense vegetation while retaining the heavy .303 rounds' ability to penetrate foliage and retain lethal effect. Across theaters, the Bren became the standard section automatic. British infantry doctrine allocated 1 Bren per 8 to 10-man section, with platoons generally carrying 3 Brens and a 2-inch mortar. Carrier platoons mounted Bren guns in universal carriers for mobile firepower. By the war's end, a British infantry division might list more than 1,200 Brens in its tables, an armored division nearly 1,400. Magazines and spares were shared within sections so that gunners rarely ran short. Neil Grant's interviews in his book The Bren Gun underscore the reaction by those who used it. From veterans' memories, there is a recurring, almost affectionate phrase, "It was a great gun, the old Bren," a testimony to both reliability and personal reliance. A persistent myth holds that the Bren was too accurate for suppressive fire, that in the chaos of retreat at Dunkirk, some sailors and commanders supposedly wished for a Lewis or other more area-saturating gun. The most famous anecdote tells of a chief petty officer advising a civilian boatman to request a Lewis because Brens are too bloody accurate. Modern testing and first-hand accounts undermine that anecdote as a universal truth. Specialists like Ian McCollum have probed the claim and argue it's a gun legend rather than a systemic problem. Controlled tests and veteran testimony show the Bren's accuracy was neither unusual nor problematic. Gunners were trained to deliver short bursts and shift aim between bursts, a standard light machine gun technique. If anything, the Bren's controllability and grouping were advantages in engaging specific targets without wasting rounds. Comparing the Bren to contemporaries clarifies design choices and doctrine. The German MG42's terrifying cyclic rate, 1,200 to 1,500 RPM, produced an unforgettable sound and lethal area suppression, but consumed ammunition at breathtaking rates. A 50-round belt could be emptied in 2 to 3 seconds. In practice, sustained rates were lower because crews had to change barrels and manage overheating. Practical sustained fire figures for both designs converge at perhaps 100 to 150 rounds per minute. The Bren's 30-round top-mounted magazine offered a compromise between portability and capacity. Its quick-change barrel kept the gun in action while preventing dangerous overheating. The American Browning Automatic Rifle, BAR, offered a 20-round magazine and lacked a quick-change barrel, limiting its sustained fire ability. The Soviet DP-28 had a large pan magazine but awkward reloads and design priorities favoring mass production over precise controlled fire. Each nation's choice reflected doctrine and logistics. Germans prioritized overwhelming volume. British planners emphasized accuracy, economy of ammo, and the realities of long supply chains. British imperial experience shaped that philosophy. Fighting in distant and varied theaters required conserving ammunition and maximizing the effect of every round. The Bren's design, the curved magazine to avoid rim lock with .303, the modest cyclic rate, the top feed to allow lower prone firing, and a robust quick-change barrel reflected real operational needs born out of colonial service and expectations of professional soldiering. With a bipod, the Bren could reach out to about 600 yards effectively. Mounted on a tripod, the gun could engage at much longer ranges with plunging fire, up to around 2,000 yards in skilled hands. The Bren's life extended long after 1945. British and Commonwealth forces used it in Korea, where they encountered Chinese-built ZB variants, a curious reunion of design families. During the Malayan Emergency and other post-war counterinsurgency campaigns, the Bren's balance of weight, lethality, and reliability made it invaluable in jungle patrols where heavier belt-fed systems were impractical. Conversion to 7.62 by 51 mm NATO produced the L4 series starting in the mid-1950s, using rimless ammunition, which allowed straighter magazines and improved feed reliability. Some 16,000 L4 guns were manufactured or converted. The chrome-lined barrel on the L4A4 variant resisted wear and corrosion more effectively. The L4 could accept 20-round magazines from the L1A1 SLR in emergencies, a pragmatic cross-compatibility measure. The Bren L4 remained in British service into the late 20th century, seeing action in the Falklands in 1982, where 40 Commando Royal Marines used L4A4s in sections that marched across East Falkland. Weight savings mattered profoundly on those long treks. The Irish Defence Forces used the brand into the early 21st century, and India's Ishapur plant produced Bren-based designs until as late as 2012, a design history spanning roughly 75 years from first production in 1937.
Many of the design features people once saw as eccentric now look like clever responses to service needs. The curved magazine countered rim lock with rimmed cartridges. The moderate cyclic rate conserved precious ammunition and made controlled, aimed bursting practical for the British fighting concept. The top-mounted feed allowed prone firing and straightforward gravity-assisted insertion during reloads. German troops sometimes collected Brens from battlefields because captured weapons were useful and serviceable. But captured Brens did not replace German doctrine or their own preference for high rate of fire machine guns. The Bren did what the British needed. It was not a universal panacea, nor was it meant to be. It was the right tool for a specific set of problems. From the mud of Dunkirk to the deserts of North Africa, from the hedgerows of Normandy to the jungles of Burma and the frozen ridges of Korea, the Bren earned its place. It was not elegant. It did not fire as fast as an MG42. It looked quirky, with a top-mounted curved magazine that blocked a straight sightline. Yet it fired when its user needed it to. It was controllable, repairable, adjustable to environmental stress with a quick turn of the gas regulator, and it let a lightweight gun team deliver accurate, decisive supporting fire. That dependability, more than any production statistic, is why soldiers remembered the Brens so fondly. The gun that initially looked awkward became the tool that rarely let them down. In the unforgiving arithmetic of warfare, where logistics, climate, and the realities of small unit tactics matter as much as raw cyclic rate, British engineering delivered what the Army asked for: a dependable, effective light machine gun that served across generations and continents. The old Bren, it turns out, was exactly what the British soldier needed.